Let's start. Hello all, let's start with our today's DSA Journey with this amazing visualizer by DSA.ChaiCode.com. Use this link to get a 7-day free trial. This is our today's question: split array largest sum. Okay, let's come to the question. Given an array of non-negative integers and an integer k, split the array into k non-empty contiguous subarray so that the largest subarray sum is minimized. Okay, and return the minimize largest sum. Okay, so it is given to us, not this one, that we are given an array. If we see here, and we just take this one, so this is given to us, this is our array. Now we have to break this array into two parts, and the 2 is always be dynamic because we are given k here. So the we are given the array and have to break this into two parts, and whatever part sum is the maximum, we need to give the minimum. Okay, so uh, let's do a dry run. Okay, so if we break, if I break the array in this part, so this part sum will become 7, and this whole part sum will become not 7, it is 10, 8, 18, 20, 25. So 25. So what is the maximum? 25. Take 25. Okay, now we have to break this array into multiple parts. We have to break this array into two parts so that we got the minimum. Okay, so let me bring the solution, and at the end we have to do a simple thing. We have to take the maximums and put the minimum, take the minimum. So let me, so if we see this right part, if we cut the array after 7, so this portion is 7, this portion is 25. Okay, so what is the maximum between 7 and 25? 25. Simple. Now after that, cut after 2. So oh, we have to cut this after 2. So 7 and 2, 9, and 10, 18, 23. So it is 9 and 23. So the maximum is 23. Same, in the same way, if we take this and put it after 5, so it will become 5 to 7, 7, 7, 14. And here 10, 18. So the maximum will become 18. 14 and 18. Just calculate the sum of the both sides. Simple. Now if we put at after 10, see, if we put after 10, we have to calculate the sum from here or here. It is 8, and it is 7 to 10, 15, 17, and 17 and 7, I think 24. So the maximum is 24 and 8, our maximum is 24. So we take 4 maximum from here. After cutting the array into two parts, we take the maximum. Okay, so we take the largest. So we take the largest of the two sums, because our objective is to minimize the largest sum. So we take this 4 maximum sum. Now what is the minimum among these 4? This 18. This is our answer. So we have to cut the array. So we have to cut the array after 5. So just take minimum of all the maximum and we get our 18. Okay, so the brute force approach, I just actually do the brute force approach here. We take for each cut position, we have to take the left and the right and put it into the largest, and we have to return the minimum largest. Okay, so this will be our pseudocode. I will not explain the brute force more than this, or I don't code it. I will do the binary search, which is important. Either if you don't want to say brute force, no issues, because we have to do the actual optimized solution. Okay, for that I need this one. Yeah. So come to our optimize. So this is our simple brute force solution. We just done it. And now the optimize one. See, suppose like we are breaking this array like multiple parts. If you see here, we break it after 7, after 2, like after 5, and calculating sum. What could be the I think this portion I should cut and put it here separately. It will be easier. So this is our array. Suppose if our k is 1, it simply means we need our array, not this k, this one. Suppose our k is 1. When the k is 1, how many subarrays we have to make? We have to make one subarray. And what will be the size or the sum? Like here we calculate sum at every step. It's like when there is a 5, we calculate sum of this part, sum of this part. So if k is equal to 1, like we need one subarray, which is nothing but the whole subarray, because there is no way. And the sum of the whole subarray will be what? What will be the sum? Which is simply become the sum of the array. And what is the sum? The sum is 10, 18, 20, 25, 30, 32. So our sum is 32. Okay. And what could be the maximum value among this uh, array of this array, which is 10? And what is our sum? 32. Does the answer lies between this? In this array, for this k equal to 2, okay, for this k equal to 2, does our answer lies between this maximum and the sum? It is simply the maximum element of this array, and it is the sum of the whole array. Okay, so does our answer, which is here 18, lies between these two? Yes, it is actually lies between these two. It is actually lies between these two. Now we have to find the solution. It is simply a binary search on answer problem where we have to find. So our total answer space is this. So the maximum sum that one single element can store, which is 10, because 10 is the maximum element. Okay, and what is 32? 32 is the whole sum of the whole array. There is nothing that goes beyond 32. Okay, in this array. So now, okay, so now we have to find the solution. So this is our low, this is our high. This k equal to 2. Now calculate our mid. Our mid will become 32 plus 10, 42 by 2, which is 21. Okay. Now, after calculating the mid, we have to ask one question to ourselves. This is the question. Can I divide it? Can I divide the array into at most k subarrays such that every subarray has some mid? So we are actually want to divide the array into k subarrays. Here k is 2. We have to cut this array into at most two subarrays such that every subarray has some less than mid. And what is our mid? 21. How could we do it? Simple follow. See, 7 to 9, 9 5 14, 14 and 10 14, 14 and 10 24. So we cannot take 24. Like whenever the sum is become, like the sum is become greater than equal to mid, or rather greater than mid, we simply stop. We simply stop. So see here, 7, 7 to 9, 9, 5, 14, 14 plus 10, 24. Okay. So if we break the array into this part, this is a possible subarray. And with this mid, we can actually get a subarray which is possible. And does this is the optimal answer? No, this is not the optimal answer. Our optimal answer is 18. So just do the simple binary search on answer. If somehow we just got we got our answer, like we can easily divide it by 21. Now we want to go to much more smaller part, so that we can get a small answer, because we have to minimize our answer. So our low will become 10 as usual, but our high will become mid, our high will become mid minus 1, 21, it is 20. Okay, so this is our high. And what is our mid? 15. Calculate it, it will be 15. Now ask again the simple question. Every time we have to ask this one question. Can we divide the array into at most k subarrays such that what is this? Such that every subarray has sum less than mid. Okay, so what is our mid? 15. So I need this. Okay, so this will be our array, and our k is 2. Remember it. Our k is 2. So 7 to 9, 9 and 5, 14. Our array is 15. Yes, because 10 is 24, which is greater than. And if sum is greater than mid, we just stop. So yes, we can make this portion with 15. But if you go to this portion, this is 18, which is greater than 15. Like, see what I want to do. Like, our sum maximum could be 15. Okay, our sum maximum could be 15. So 7 to 5, 7 to 5, it will add up and become 14. And if we add 10, then it will become 24, which is greater than 15. So we just break the array from there. Okay, now 10, 10 is less than 15. Okay, then 10 and 8, 18, 18 is less than 15. Okay, too dark. 18 is less than 15. No, no, simply break it here. Does now the 8 is less than 15? Yes, but for this 15, for the mid 15, we have to make sure. Okay, for the mid 15, we have to cut our array into 3 parts. This one the first part, this one is the second part, this one is the third part. And what is our k? 2. So this 3 is greater, or rather 3 is not equal to 2. Okay, so 15 is not our answer. We have to increase it. 20 is our answer. If you see into this previous one, 7 to 5, 14 is our answer. If you add 10, it will become 24. We don't have answer. 10 plus 8, 18 is our answer. We can easily break it here. Okay, 21 could be our answer, but we need a minimum one. So when this will happen, simply do high equal to mid plus, sorry, not high, low equal to mid plus 1. So what is our high? High at 20. and where is our low? 15 plus 1 will become 16. 16 will become our low. So now calculate the mid. Our mid will become 20 plus 16 into 36. 36 is 18. We got 18. Okay. Now get the array and now break it. Our k is 2. This 60 we have to calculate with 18. 7 to 9, 5, 14. 5 plus 10, 24. We don't know it. Cut it. 10 we can take it. 8, 18. Yes, 18 we can take, and with 18 we cut the array into two pieces. This one is the first piece, this one is the second piece. Simple. And this will become our answer. Okay, we also try for minimum. When the next step, the 16 will become L and our high will become 17. And if we go and calculate with this, like the mid will become 16, 16, 32, 16. 30, 33 will be the sum. So 16 will be our mid. And if we go with 16, like simply 7, 2, 5, 10, 8. So if we go 7 plus 2, 9 plus 5, 40. Cut it, because that if we add 10, it will become 24. Now 10 plus 8, 18. 18 is greater than 16, so cut it. It will become 3. And after that, it will goes to the same portion, like the low will goes to here. Even if it is not possible with 16, it is not possible with 17 also, if you go and check, because this sum will become 18. So our answer will become this 18. And after we get a successful answer, we will store into a variable. Okay, so this is our simple pseudocode. Every time we have to ask it, can we divide the array into at most k subarrays such that every subarray has sum less than equal to me? This is the simple question we have to ask every time. Okay, now this one, should I write it this one or this one? I think this one will helpful because everything is black. No I strain. Okay, so simply we are given an array and a k. Our L will become, what is our, at the starting, what we did at the starting, L is our maximum of the array. Why? Because if we take one element into one subarray, only one element, and the maximum that can be is 10. So our L will be max of array. And what is our R? R will be the total sum. Okay, because at most we can hold the total sum. Okay, so R will be the sum of the array, while L is less than R. Calculate the mid, which is L plus R minus L by 2. And rather than taking L, I actually take it H here. So I'm just taking H. Now check if K subarray possible with mid. What this line does, this line does the simple thing. It will go and ask this question too, that can we break the array into at most k subarrays such that every subarray has sum less than k. It will simply ask this question. Then see if it is possible. If it is possible, then do simply two steps. Our h will become mid minus 1, and our answer will become mid. And if it is not possible, simply do our L will become mid plus 1. And at the end, just return the answer. Let's evaluate it. Oh shit, I just and do like this is for that purpose. This should be equal to, I miss that equal to, sorry. I think now it should, yes, it is running perfectly. So our pseudocode is this one. This is our pseudocode. Now let's, I already have this. Okay, let's write it again and explain it while writing also. So what we are taking here, just take. First we are taking the maximum of the array and the sum. Okay, so first take the size, nums dot size, then take take two variable. One is low, at which actually we need the maximum element. So let's do this. It doesn't violate any condition. At the starting it is 0, because I think there should not be any negative values, because every value is from 0 till 10 to the power 6. The length is always in the positive, and every value is positive, it should work. No worries. Take a for loop starting from 0 till the n. The low is the maximum of the element. So we calculate low like this. We iterate the whole array and we until we get the maximum. Okay, and the right will simply become the summation of that whole array. So we get our low and high ready. Now we have to do the simple binary search operation. Low is less than equal to high, and here we calculate at the first the mid, which is simply mid equal to low plus high minus low by 2. Okay, and now after calculating the mid, we need to check the subarray is possible or not. So what we can do is, let's write a function. Okay, and the function give us how many number of cards we have to make into the array to satisfy the mid. Okay, simple. So simply say count is possible. It will take the nums and the mid. Simple. Now if the count, if the count is simply like we get our mid. Now with this, with the value of the mid, how many cuts we have to make, or how many number of subarrays we have to make into the array so that it satisfies the condition of the k. Okay, if count is less than equal to k, if anytime the count is less than or equal to k. It simply means that we got our answer. Simply do one thing. Our high equal to mid minus 1 and our answer will become mid. Okay, and also we don't initialize our answer, so our answer will become minus 1, and else simply go low will become mid plus 1, and simply do return answer. Now write this one. This is possible, so it is possible. For it will take these two things, not this k. Obviously it will take this mid, and here we have to first take two variable. One is count 0, actually we need one, so, and take a temporary sum as 0. Okay, now if and not if, uh, run a for loop. I calculate this in also. You can pass this in. Let's pass this in also. What's the problem of taking just one variable? For int I is equal to 0, I less than n, I plus plus. Simply do one thing. One check. If the temporary sum which you have plus this nums of I is less than equal to mid, it is simply less than equal to mid. We just have to add the sum. Okay, so here do this thing. Let's do this thing. And else it simply means that we cannot add more variable, and when we cannot add more variable, like here, when we cannot add more variable, we just put a cut, and our cut is simply count. Okay, our count, and also update our temp sum. So our sum will now be start with this element, and at the end do a count plus plus, and then return count, and just run it. Unknown server error, please contact support team. I don't know. Low and right, this will become high. Low and high, left and right. Yeah, it's working. Let's try to submit it. It's working perfectly fine, but maybe the things arise that why another count. Okay, and let's explain this with this example. And suppose when we reach our answer, our mid will become 18. Simple. Our mid will become 18. We got our 9, and we just take the count and temporary sum. Okay, simply do our temp sum, ts, at the starting it is 0. Okay, and our count at c, it is also 0. So first we go to 7. So 0 plus 7, it is greater than 18? No. So add 7 here. Now goes to 2. So 2 plus 7, see, I just apply this. I am just applying this. Okay, 2 plus 7, 9. It is less than 18? Yes. So do 9. 5. 9 plus 5, 14. Is it less than 18? Yes. Add it. 14. Now 14 plus 10, 24. It is less than 18? No. Where it will go now? Count. So our count will become 1. And it goes our temp sum as nums of I. Our current hour I is at 10. So our nums of I will become 10. Simple. Or 10. Now 10 plus 8, 18. 18. We reach 18. Is it less than equal to? We are using less than and equal to. Is it less than equal to 18? Yes. Add it to the sum. And now we reach our last index. We go out of the bound. Now if I don't add this at the end, okay, add this at the end, it will give us a wrong answer for every cases. Yeah, because why? Now I am sending this count equal to 1, not count equal to 2, because we have to calculate it into 2 pieces, 2 arrays. So it will become 2 when we add it, because when we cut the array here, we don't cut it, we just take the count. Okay, so we take this count as 1, but we don't take the last count. So we have to take the last count, the last subarray. Okay, so for that we need to add this count here. This is just for the last subarray to count, because that is also a subarray. We have to count that also. Like if you consider this two, like this is one group rather than subarray, this is one group, this is another group. You can easily think like that. So we count this group, but we don't count this group. We have to count the last group also. For that count of the last group, we take this count plus 1, count plus. But if you don't want this, you can start it with 1 also, and then you just comment this. So if you do this, this will also work. See, if I submit it, it should work. Yeah, it's working. It's working. And another way of doing the code, I am just changing the code sometimes, like we are taking the count of the is possible and then calculate it. Okay, so what if we just took this one here, like I'm just passing the k here, I'm just passing the k, change it to bool, change it to a boolean, pass the k here, and take this whole is possible and put it inside if. Remove this count, sorry, remove this count. Is it working? Can we submit this? Yes, we can. But why and how? See, let's change it to 0 and bring it back. So in the previous code, we do the calculation inside the if statement. Now after calculating all the count, we are returning the count, we are actually returning the count previously, and make this same calculation inside the if, inside this if statement. But now we count the whole thing, and we check it, we just check the count and its possibilities, that is it is less than k inside this is possible block. Okay, and then just check the is possible block here. So previously we take the count, we check it into our split array function, inside this if statement. But here I just check everything inside this is possible function and just call this is possible function into my if. Okay, if we run it, it will also give the same answer. No worries, just we change the code, we change the value, anything is possible, both of have the same answer. Okay, so what is our time complexity? Big of n into sum of the array. Okay, so our time complexity will become big O of n into log of sum. Let's take s. So if you see it here also, n log summation. Why summation? Because our maximum, actually we are taking the high as the summation. Okay, and why n? Because we are traversing the array at the starting for the whole array, and then binary search onto on that sum. So that's why n log s. And I don't think any spaces we use. We don't use any spaces. We just use variables. So it is big O of 1 in space. So our space complexity will become big O of 1. So this is the solution of the question. Split array into largest sum. Use this link to get a 7-day free trial. Use this platform here at dsa.chaicode.com. Go check out this platform here. Any version is possible. Dark mode, light mode, anything. Thank you. Thank you very much.